Right, the purpose of this video is to find the area between two curves, and we're going to do so using desmos as our technology. So for this particular problem, our first function is y is equal to negative root x. That's the bottom part of this curve right here. Y is equal to positive 3 root x. That's the top part of the curve right there. On the left, we're bounded by x is equal to 0. On the right, we're bounded by x is equal to 4. So we want to find this shaded region in here. So I'm going to need to create this graph in Desmos. So what I'm going to do is I'm going to make my f of x to 3 root x. That way it lines up nicely with the formula that we need to use. So f of x is equal to 3. And then get my root x here. So there's the top of the curve. I'm going to make my g of x the bottom of the curve, which is negative root x. All right, so that looks pretty reasonable. It's not necessary as far as the calculations we have to do, but just for visual emphasis of the graph that we create matching what's given to us in the problem, I'm going to do x is equal to 0. It's a vertical line for the left bound. X is equal to 4 is a vertical line for the right bound. So this area in here is what corresponds to that. All right, now in order to get that area, I'm going to get my toolbar back again. Go to Functions. It's under Miscellaneous. And we have our integral symbol. So by the formula, we need the left bound or the lower bound here, the right bound or the upper bound there. So we're going from 0 to 4. All right, by the formula, it's the top curve minus the bottom curve. I already set this up so the letters match as it appears in the formula. The top curve is the 3 root x. That's my f of x. And then I'm going to subtract the bottom curve, which is the g of x. And then we are integrating this with respect to x. And we get the 21 point repeating 3 for the area of the shaded region. All right, one of the potential disadvantages of using technology is we're not necessarily going to get the exact area. Now, it'd be safe to assume here with this problem that's 21 1/3. But if this were a radical answer or something that was in terms of pi, it may not be recognizable in terms of what the exact solution would be. For what we're accomplishing in this unit in our class, the decimal approximation is good enough. It's good enough for the worksheets associated with what we're going to be doing, good enough for the quiz that you're going to take on this stuff.